Welcome back to The Explainer. Today, we're diving into a genuinely fascinating piece of theoretical physics. We're looking at a brand new addendum to the Rihan atomic model, put together by independent theoretical physicist and mathematician Dr. Ahmad Rihan. And we're going to explore a pretty wild idea. What if the stability of the atom, the literal foundation of our physical world, doesn't need any arbitrary inputs to hold together? What if it actually emerges naturally, just from pure mathematics and geometry?
Okay, let's dive into this. For a really long time in physics, one of the biggest, most fundamental puzzles has been atomic collapse. I mean, think about it. Why don't negatively charged electrons just crash right into positively charged protons? Classical physics told us they absolutely should. But what Dr. Rihan proposes here is that the solution to this problem isn't just some forced, clunky equation. Instead, what if atomic stability is an inevitable consequence of geometry? It's like the universe is balancing the atom using just a few fundamental constants as the ultimate blueprint for reality.
Section 1. Rihan Atomic Model.
To wrap our heads around this baseline framework, we kind of have to shift our perspective entirely. So go ahead and forget that classic high school image of the atom as tiny static dots orbiting a center like planets. Actually, the Rihan atomic model uses what are known as Gaussian surfaces. Think of these as dynamic, continuous, ball-shaped envelopes. Now, because of the Heisenberg uncertainty principle, which basically means quantum particles can never just sit perfectly still, these surfaces have to constantly revolve and evolve so they don't collapse classically. They exist in this continuous, non-static state. They're active, moving, geometric spaces. But of course, that begs a question. What exactly is dictating how they move?
Section 2. 3 Constants of Nature.
Now, what's really interesting about this slide is how Dr. Rihan assigns tangible, physical roles to numbers you probably remember from high school math. First up, we've got pi. In this model, pi literally represents the spherical geometry of those Gaussian ball surfaces. Second, there's Euler's number, E. This one embodies the exponential spiral dynamics of the electron, which operates kind of like a string. And third, we have alpha, the fine structure constant, which sits at roughly 1/137. Alpha governs how these charged particles electromagnetically interact with each other. So these aren't just abstract, floating numbers. They are the active agents actually building the atom. So what happens when we mix these ingredients together?
Section 3. Calculating proton speed.
Well, it brings us to this wonderfully elegant equation. By applying an effective Lagrangian, which, if you need a quick refresher, is essentially a mathematical formula for tracking the energy of a moving system, Dr. Rihan combines our three agents. We take the spherical integration, represented by pi, the helical torsion of the string, represented by e squared, the charge interaction limits, represented by alpha squared, and we multiply the whole thing by the speed of light, c. This formula actually calculates the exact inevitable orbital speed of the proton's surface.
And the result of that elegant little formula? It comes out to approximately 158 kilometers per second. Now, I know what you're thinking. In the grand scheme of quantum physics, that is a relatively slow, non-relativistic speed. But honestly, that is exactly what the model requires. This speed is perfectly suited for the continuous collective revolution of the protonic Gaussian envelope. It moves just enough to satisfy the uncertainty principle without, completely flying apart.
Section 4. The relativistic spiral electron.
Let's move on and see how this builds, because we've looked at the slow-moving proton, but the electron is a completely different beast altogether. To visualize the electron's movement, the paper uses a pretty striking biological metaphor. The model defines the RAM electron as a relativistic spiral string, specifically described as sperm-like. It's got these highly condensed frontal turns and a long extended tail. And as this complex, multi-axis string whips around at absolutely incredible speeds, all guided by Nambu-Goto-inspired string dynamics, by the way, it rapidly traces out a spherical, ovum-like Gaussian envelope.
And this extreme juxtaposition is absolutely crucial. It's at the very core of atomic equilibrium. Think about it. On one hand, you have the proton. It's doing this slow collective revolution at around 158 kilometers per second to form a spherical envelope. But on the other hand, you have the electron using highly energetic helical string torsion and zipping around near the speed of light. Managing the delicate balance between these two insane extremes is the central puzzle of the atom. How do they not just tear each other apart? Well, the theoretical solution to that puzzle lies in achieving perfect equilibrium.
Section 5. Perfect momentum balance. So the model achieves what's called mechanical and electrostatic equilibrium, or MEE, and it pulls us off through a step-by-step net momentum velocity balance. Step 1, we start with the spherical integration of the protonic envelope. Step 2, we introduce that extreme torsional spiral motion of the electron string. And then step 3, electromagnetic coupling steps in to strictly enforce a net momentum balance. By working through the complex math of minimizing energy, specifically using variational minimization from Euler-Lagrange equations, we see that the universe naturally selects these specific equilibrium speeds. The action is minimized, zero net torque is maintained, and boom, atomic collapse is prevented.
Now here is where it gets truly incredible. So, the crucial point is, when we take that relatively slow speed of the proton, and we scale it up by the proton-electron mass ratio to find the exact speed the electron needs to maintain that momentum balance, we get this number, 290,702 kilometers per second. That is astonishingly close to the actual speed of light, which is 299,792 kilometers per second. The math naturally pushes the electron's speed right up to the relativistic limit.
Now, you might be wondering about that slight gap between 290,000 and the absolute speed of light c. But it's important to note that this mathematical gap isn't a failure of the model. Not at all. It's actually a natural result of string approximations. The discrepancy basically comes from things like Gaussian width parameters, the averaging over distributed strings instead of just simple point charges, and the need for higher-order relativistic corrections in the full Lagrangian. So it perfectly bridges the gap between complex string theory and the observable atomic scales we're used to.
Section 6. A new unifying framework.
Let's zoom out for a second to look at the broader philosophical and physical implications here. And this brilliantly illustrates the core thesis of Dr. Rehan's addendum. As he states, it transforms what could be seen as coincidental numbers into a coherent narrative of natural emergence. We didn't have to force arbitrary parameters into a supercomputer to make the atom stable. The parameters are an inevitable, beautiful consequence of geometric and dynamic laws. Pi, Euler's number, alpha, they are literally the underlying narrative of natural emergence.
And for the focused learners out there wondering, okay, is this all just purely abstract math? I can assure you it is not. This theoretical framework provides real, concrete, falsifiable predictions that can be tested in physical reality. The derived speeds and dynamics we've talked about can be scrutinized through molecular dynamic simulations, they can be checked for consistency against actual nuclear scattering data, and they can be tested with high-precision spectroscopy or atomic clocks. It brings all those deep, theoretical string dynamics right down into the realm of the testable atom.
Which brings us to our final thought for this explainer. We've seen how pi, Euler's number, and the fine structure constant seamlessly weave together to naturally balance the massive, slow proton with the lightning-fast spiraling electron. It really makes you wonder, if the universe's ultimate building blocks are just inevitable expressions of pure geometry, what other mathematical harmonies are hiding in plain sight?